Hello friends, welcome to our channel. In this lecture, I would like to explain another example based on the circular column. See here in the question, design a circular column to carry an axial load of 1000 kilonewton using lateral ties. Use M20 grade concrete and Fe415 steel. So while talking about the circular column, we have to use both lateral ties or else we can use spiral columns also. Okay, it in the form of spiral like this. So we have to provide spiral for the longitudinal bars. So we will discuss that thing in the further classes. So here by using lateral ties we are going to design a circular column. We don't know the diameter of the circular column, so based on the given data first we have to find out the circular column. So first take down the given data. So what is the given data here? Axial load, so that is P will be equal to 1000 kilonewtons and M20 grade concrete, that is FCK equal to 20 Newton per mm square, and Fi which is Fe415 steel, Fi will be equal to 415 Newton per mm square. So for solving this formula, already I told you, for solving this problem already I told you one formula which is given in our Indian Standard 456 book. So see here, short axially loaded members in compression. So here the page number will be 71 in IS 456. So already we solved one or two problems in the previous lectures also based on this formula. So you please take down the same formula, that is PU equal to 0.4 FCK AC plus 0.67 FY ASC. So which was in the class 39.3. So I am clearly mentioning that one. So in the IS 456 2000 page number 71 class 39.3. So by using this formula we have to design the problem. See what is the formula? That is PU equal to 0.4 FCK AC plus 0.67 Fy ASC. See here the formula will be in terms of PU, which is factored load, but what they will mention in the question, they are given that just axial load. So if you want to take down in terms of factor, that is PU will be equal to 1.5 times of the given axial load. So that is 1.5 into 1000, that one will be equal to 15,000 kilonewtons. So that can be in terms of newtons, means 15,000 into 10 to the power of 3 newtons. So that is the factored load value. So that is 1500 into 10 to the power of 3 newtons. And what are the remaining things here? FCK is already given in the question and Fi also already given in the question. If it is not mentioned, means assume your own grade of the concrete and grade of the steel also. So there will be 3 grades of the steel, that is Fi equal to 250, 415 and 500. So it is always better to take 415 or 500 if it is not mentioned in the question. And there will be various grades of the concrete taken from M5 to M25. There will be some nominal proportions also, and above also there will be some grades. But according to IS standards, the minimum grade of the concrete we used to take is M20. So it is better to take M20 always if it is not given and above the M20 value. So here FCK value is 20 and Fi value is 415. But here there will be two unknowns, one will be area of the concrete, another will be area of the steel. So for that purpose, what we have to do means, first assume this area of the steel as 1% of the gross cross-sectional area. So area of the steel will be equal to 1% of gross cross-sectional area. So this is a circular column, it will be in the form of the circular like this. So entire gross cross-sectional area will be in terms of pi d square by 4. So we are just assuming overall gross cross sectional area, in that 1%, so area of the steel will be equal to 1% of the gross cross sectional area. So that one will be equal to 1 by 100, which is equal to 0.01 times of Ag. And again, so here in this overall cross sectional area, so there will be area of the steel bars, at the same times concrete also included. So we know that one. So if this is the entire circular diameter, so circular column. So if overall cross sectional means there will be area of the steel and area of the concrete. So we are assuming 0.01% of Ag. If you want AC means just send this one this side. That is area of the concrete will be equal to Ag minus 0.01 Ag. That one will be equal to that one will be equal to 0.99 Ag. 1 minus 0.01 will be equal to 0.99 Ag. Therefore, area of the concrete will be equal to 0.99 Ag. So, almost all we have all the values. So, this one will be equal to 0.99 Ag. So, you will get the value in terms of Ag because here unknown in Ag only. So, substitute all the values. Pu will be equal to 1500 into 10 to the power of 3 newtons and 0.4, where FCK is 20 and area of the concrete will be equal to 0.99 Ag plus 0.67, Fi is 415 steel and area of the steel will be assumed as 0.01 times of Ag. So if you simplify, you will get the value of Ag, that is Ag will be equal to 140186.9 mm square. Maybe the value which is more or less to this value, approximately 190 or 185, you can assume 140, 190, 140, 185. Based on your calculation approximation, you will get that value. So here my obtained value will be this one, that is 140186.9 mm square. After obtaining this value, so whatever you are assuming area of the steel, you just multiply that one 0.01 into this value, that one will be equal to 140186.9. So how much you will get area of the steel will be equal to, so therefore area of the steel, if you simplify that one, you will get area of the steel will be equal to 1401.9 mm square. This is your area of the steel. Okay, then go to the next part. So this is the overall cross sectional area of the particular column. So we people know that one. In the last time we calculated one problem based on the square column. So for square column, it will be in terms of b by b. Both sides are equal. Okay, therefore we are assuming b square equal to ag. But here it is a circular column. For that one, your ag will be equal to, area will be equal to pi d square by 4. So I am taking pi capital D square by 4. For example, if you take any rectangular column like this, so the sides will be in terms of some a by b. So at that time you used to take a into b. Then you can find out first of all any one value, a divided by a value will be equal to 140186 divided by b. Based on that you have to calculate a rectangular column separately. But here they will given one circular column. For that one, area of the square will be circle will be equal to pi d square by 4. So I am taking as it is that value. That one will be equal to pi d square by 4. That one will be equal to 140186.9. Then simplify that one, find out the d value here. So cross multiply 4, so this one will be 4 into this value and again send this pi downward side. Finally d square equal to some value you will get and again d equal to square root of entire this value. So whatever the value will simplify. Like that, if you simplify directly by using your calculators, you will get approximately equal to some 422 or 423 in mm around. So you will get this value. So whatever the value will get, so it is not better to take down as it is whatever the value will get. So you can round off any one value which is very near to that one. So maybe some 425 or 430, but keeping the sizes in means like in small threads, it is very difficult in the practical consideration. Therefore we are assuming this one will be approximately equal to 430 So don't round up this one to 420 below this value. Why? Because already the value whatever you are choosing, it will be above 420. Therefore you can round up to the next bar, like after calculating number of bars equal to 3 means you can round up this value to 4 for minimum bars of the square column, not for 2. Like this you can go to the next best value, but while keeping spacing means you can choose minimum value. If you will get to 250 around 251 point something around means you can choose 250. So some standard conditions will be there. So always better here you can take down 430 which is the next better value around higher value. Then after opening this one, choose diameter of the circular column. So the property of the circular column will be equal to 430 in terms of So for this one, already we know the area of the steel, that one will be equal to 1401.9 square. So for this one, you please provide the bars, number of bars. So already we people know that for square column, minimum number of bars will be equal to 4, and for circular column, so the minimum number of bars we are using, that one will be equal to 6. Therefore, check the trials based on the 6 bars. So 6 into, my first trial is 6 into pi. I am assuming the diameter bar of, so I am assuming the diameter bar of 16 I am coming from 16. So the minimum diameter bar required for the footing will be 12. If you choose 12 means you will get very minimum value. You want means you can check that value. So therefore I am going to the next best value, which is 16. So diameter will be 16. So pi d square by 4. If you simplify this one, so my diameter here will be equal to 16. For this one, you will get around 1205.76 square. But see here, this is the required value for that particular column. So therefore, whatever the value you are choosing, it will be higher than the required value. So therefore, the value here, it will be lesser than the required value. So it will be lesser than the required. So therefore, we are not preferring this value. Then go to the next dia, which is diameter will be equal to 20 So therefore, I am checking on based on that 6 into pi 20 square by 4. That one will be equal to 1884 square. If you simplify this one directly, you will get. So this value will be greater than area of the steel required. So whatever the value we are obtaining based on the 20 diameter square, it will be greater than this one. So here you can, if you want means you can fix this one. Otherwise you can check with higher bars. For example, minimum number of bars will be 6 means you can provide more than 6. Is it convenient? And again you can check the bars based on the 6 meters only. So I will tell you that one also. See here, I am going for the third trial, that is trial 3. So I am choosing diameter of 8 So for that one, sorry, 8 number of bars, I am preferring 8 number of bars is 16 dia. So therefore 8 into pi 16 square by 4. If you simplify, you will get the value of 1607.6. So this also area of the, so the value whatever obtained here, that is 1076.6, will be greater than the area of the steel required. So whatever the steel you want means this one. So according to your convenient, you provide the steel. So here there is a chances of providing both this one. So whether you can provide this one or else you can provide this one, no problem. So if you have longitudinal bars of 20 availability on the site, then you can prefer directly this only, or else there will be 16 dia bars available in the site means you can prefer this only. So it is your convenient. Why? Because both the areas will be higher than the required. So here I am selecting the value which is, I am providing 6 bars of 20 dia. So provide So I am providing this value, provide 6 bars of 20 mm dia. So that is the area of the steel we are providing here. So for this one, what is the value obtained here? That one will be equal to area of the steel provided will be equal to 1884 mm square. If you want, you can choose this one, but here it will be economical comparing to this one. So it is your wish, whatever you want, you have to provide that only. Okay, then move to the next step after obtaining all these things. So next, to provide the lateral ties. So that is, so this lateral ties will be in our code book, that is page number 49. See here, page number 49. So this is the page number 49. Here they will mention that is lateral tile. So that is the class 26.5.3.2 C. So here the pitch of the transfer reinforcement shall be not more than the least of the following. So then the diameter of the polygonal links lateral tie shall not be less than 1/4 of the diameter of the largest 4, and in no case it will be less than 6 mm. So already in the last class itself I told you it is 6 mm, not 16 mm. So first based on that, what they will mention in the diameter column. So it will be 1/4 of the diameter. It does not. So diameter of the lateral tie should not be less than. First step will be this one. So what is the diameter we have chosen here? We are chosen 6 bars of 20 dia. So you can choose that one. 20/4 will be equal to 5 mm. And another condition will be, so that it does not less than 6 mm. So out of these two values, we can choose the diameter of the lateral ties should not less than. So based on the first condition, you will get 5 mm, and second condition 6 mm. Means minimum bar we have to choose according to our condition will be 6 mm. Okay. For example, after solving this one, if you use some 25 dia bar, so based on that one first condition, what happens means you will get 4 6 times above, you will get the value, like 6 4 ja 24, again 5 means 4 6 15 4 3, like that, some around 4, which is 4 value higher than this one. At that time what you have to do means, so here second condition will be 6 mm, but you can choose it should not less than these two values. For example, at this time you can go for minimum 6.3 diam stirrup will be required here, lateral tie will be required here. So there is no 6.3 diameter bar will be available in our market. So next best value is, which is 8 mm. So mild steel will be available from 6 mm and HYSD taken from 8 mm. So go to the next best option, which is 8 mm. So in this condition you can prefer minimum 8 mm bar as a lateral tie. Okay, 8 mm dia bar as a lateral tie. But here first condition will be 5 mm, second condition will be 6 mm. So here it does not less than 6 mm, first will be 5. So that is the reason you can prefer it does not less than 6 mm value. So if it will be higher than the 6 mm, then provide next best value which does not less than that value. Okay, then next condition will be pitch. Pitch is the just in the beams we used to call as spacing. Here it is pitch in the columns. So what about the pitch? For pitch there will be three conditions. The least lateral dimensions of the compression member. So what is the least lateral dimensions of the compression member? So least lateral dimension of the compression member. See here, what is the least value here? For example, if we are solving square column 420 by 420, so there will be both the columns will be equal in size. So therefore you can take any one of the value. For example, if you have to solve rectangular column, there is 300 by 500. At that time you will get one least value, one higher value. So there you can choose least value as 300 mm here. But we are solving here circular column of dia 430 mm. So here there will be only one dimensions, that is only least and that is only highest. Therefore here we are taken that is 430 mm. And our next condition is 16 times the smallest diameter of the longitudinal reinforcement. 16 times of the smallest diameter bar. But in our problem we are using 6 bars of 20 dia. So for example, For solving that particular area of the steel, we used some 6 bars of one dia, 4 bars of one diameter, and another 2 bars of another diameter. Means at that time we can choose lesser bars, but usually in the circular columns it is better to prefer uniform bars. But while solving rectangular or circular columns, if we are providing some 8 bars, means there is a chances of providing some 6 bars of 4 bars of 1 diameter 20 dia and 4 bars of 16 dia. At that time you have to choose smaller diameter as 16 bars, but here there will be only one diameter bars we are choosing. So I will explain in the further classes if you will get any such type of conditions. Different dia bars we are using, means I will show you there. Here we are using only one dia bar, which is 20 mm. So then directly take down the value 16 into 20. So how many times it will go? 16 into 20 will be equal to around 320 mm. So take down the 320 mm as it is, and the third condition will be 16 mm. uh, Third condition will be 300 mm. 300 mm. Okay, 300 mm. So see here, out of the three we have to follow the least value. So 430 will be higher value, 320 will be higher value, 300 is the least comparing these three. So therefore we are providing pitch of 300 mm. So in the Indian standards there will be one small mistake here, that is 16 mm like that. So you please change this value to 6 mm, round off this value to 6 mm only. So it is mistake, printing mistake there. Then give the statement, that is so provide lateral ties of 6 mm with 300 mm pitch. Okay, like that you have to find out the lateral ties and pitch value. But some after solving this one, sometimes if you are using 16 diabars like that, so you will get 16 into 16, how much it will be? So I will tell you that condition also. 16 into 16 means you will get 256 around here. Okay, but see here, one will be 256, another will be around here. Also least lateral dimensions of the column will be 430, and here 300 mm. So in these three, 256 will be the lowest value. At that time you have to prefer 256 only, but after solving these three you can choose whichever is the least value. Then go for the detailing of the reinforcement. So here we are using 6 bars, so circular column of 430 dia, and so actually first they are providing longitudinal bars, then stirrups, but here I am taking that stirrups will be first. Okay, with some giving of cover gap, and again I am providing the 6 bars. With equal spacing. So all bars are uniform dia and uniform spacing only. So this is the top view. Okay, so these are the diameter bars. So here the dimensions of the column will be 430, the diameter, and after removing this cover you will get the stirrups. So here provide lateral tie. So lateral tie is around we are preferring 6 mm lateral tie. Okay, and dia bars, 6 bars of 20 mm dia. Okay, so this is the cross section. This is the cross section. For example, if you cut anywhere in the section and see from this view, so what is the elevation? So elevation always check like this. So taken from here you have to project along like this only. So always you can choose the elevation like this. Okay, here also. Then longitudinal bars for this projection. Likewise, you have to project this bar and you have to project this bar as it is. And provide this lateral tie of a 6 mm bar with the equal spacing of 300 mm, like this. So this is the continuation column. This is also okay. So please give the detailing here also, like longitudinal bars of 6 bars of 20 dia, and the lateral tie will be of 6 mm lateral tie, and the spacing between these two, so the spacing between these two will be equal to around 300 mm. So this is the elevation of this particular cross section. Like this you have to give the detailing of this circular column also. So but you remember one point, for circular column it will be minimum 6 bars are required, for square and rectangular minimum 4 bars are required for the columns, and minimum diameter bar used for longitudinal reinforcement will be 12 mm. Okay, all these are the important things what you have to find out. For example, if you are using in place of lateral tie, spiral helical reinforcement used to call. So for that one I will show you roughly here itself. So see here, for that one, so in place of these lateral tiles you will get the spiral like this. So in the cross section view, so roughly what I am telling means like this, it is in the form of spring of equal dimensions. Okay, so we used to solve the type of models also in the upcoming classes. So I hope you understand this lecture. If you really like this video, please like this video, share it to your friends and subscribe our channel. Thank you so much.